So today, what we're going to go ahead and look at in Calculus 1 is a section that starts with the limit laws. That's part of what this section has to do with. So to begin with, I'm going to go over all these limit laws. These are important things to know for calculus because we use them all the time later as we learn about derivatives and integrals. So it'll help you understand the theory behind what we do a little bit later. So what I'm going to do is just kind of go through these, an example of each one. I'm going to start with the sum law. And on the sum law, this says if you do a limit of the sum of two functions, well, you just break it up into the two functions. And you get the answer to the first limit plus the answer to the second limit. Okay, so I'll just have you fill in an example for each one. So let's go down the bottom of the page. So here's an example. The limit as x goes to 1 of ln x plus e to the x. So what we would do on this, to demonstrate this with the limit law, you would do the limit of the first function, which is ln of x, and then x goes to 1, be sure you put that in there, plus, and then the limit of the second function, e to the x, as x approaches 1. All right, so what we do then is we just plug the number in. So we would just do ln of 1 plus e to the first. And what you would have is ln of 1 is equal to 0. Hold on, teacher. That's got to be a 1. Okay, so plug in the 1. So you get that. So you'd have 0 plus e. So that would be equal to e. Okay, that's how that law works. Second law we have up here is the difference law. Just works the same way as this one. If you have a limit of two functions subtracted, you do the limit of the first minus the limit of the second, and then the answer is just the value of the first limit minus the value of the second limit. So this works the same way. Let's use this trig example. So what we would do on this one is we would write this as the limit as x approaches pi over 2 of sine x minus the limit as x approaches pi over 2 of cosine of x. So that's how you would put that together. And then you just evaluate these limits. So you'd plug in the pi over 2, so you get sine of pi over 2. You want to remember the unit circle. Evaluate the next one. That would be cosine pi over 2 like that. All right. And what you would end up having on this then is essentially this. At pi over 2, on a unit circle, have you 0.01. And remember, the cosine is the x value. The sine is the y value. So what you would end up getting on this is the sine of pi over 2 would be 1. The cosine of pi over 2 would be 0. So the answer to that would be 1. Okay? So this is just demonstrating how you use these various laws. Okay, the third one is the constant multiple law. So what that says, if you're doing a limit of a constant c, that c stands for a constant. And what I mean by a constant is that's just some real number. It's not a variable, it's a real number, any real number. Okay, so according to this, what you can do, if you have a limit of a constant times a function, that comes out in front, and then you have c, the value of the constant, times the limit of f of x. So L is the value of the limit, you end up just doing c times L. So let's take a look at this example down here. Okay, so this one, pi is a constant, and it's multiplied by the tangent. So that would come out. You would write this as pi times the limit as x approaches 0 of tangent x. Then you evaluate the limit. So you'd have pi. You want to evaluate the 0, so you'd have times tangent of 0. So on a unit circle, at 0 radians, you're at the 0.10. Remember, the tangent, the value of the tangent of some angle theta is y over x. So in this case, you would have y is 0, x is 1. So therefore, we would have 0 over 1, or 0. So the tangent of 0 radians is 0. So this would give pi times 0 Therefore, the value of that limit is 0. Every one of these problems, you could put the function in the calculator and tell that you're correct. We want to try to get away from having to graph unless we absolutely have to. Okay, so the next thing I'm going to look at is the product law. The product law says if you have the limit of the product of two functions, then you do the limit of the first function f of x, the limit of the second function g of x, then multiply together. And then the value of the first limit is L, the value of the second limit is M. You end up just multiplying those two things together. So let's do one example on this then. Okay, so the product rule, we're going to do the limit of x multiplied by e to the x. So two functions, x and e to the x. So what you do is you do the limit as x approaches -1 of the first function x times the limit as x goes to -1 of the second function e to the x. That's how the limit law works. Then you work this out. Plug in the -1 into x, you get -1. Plug in here, you get e to the -1. So you would really just get negative e to the -1. And it's okay to just write the answer that way. Okay? You could also write this out one more step if you wanted to. Just -1 over e to the first, or -1 over e. Okay, so that's how that works. The quotient rule works a lot like the product law. So if you have the quotient, that just means if you have a quotient of two functions, as x approaches a, you do the limit of f of x, the numerator, divided by the limit of g of x, the denominator. The value of f of x's limit is L. If the value of g of x is M, you just get L over M. This thing right here, of course, just means is a denominator can never be equal to 0 in a fraction. So you got to make sure that the denominator is not equal to 0. So the way we would work this out would be like this. Okay, we would just say, down for the quotient rule in this example, we would say the limit as x goes to pi over 4 of the secant of x divided by, and then we would do another limit. We'd do the limit as x approaches pi over 4 of cosecant of x. And then we're going to go ahead and we're going to work this out. I'm just kind of looking at the unit circle on this a little bit then, and this is a good trig review. So if you have pi over 4, when you have the angle pi over 4, which is 45 degrees, you have the point on the unit circle, square root of 2 over 2, square root of 2 over 2. I recommend early on in Calc 1 that you remind yourself of the unit circle. You should have learned that in pre-calc or trigonometry. So what we have then is this. You have the secant of pi over 4. The secant's definition is r over x. Okay, it's the reciprocal of the cosine. In a unit circle, r is 1. The x value is square root of 2 over 2. So you're really doing the reciprocal of that. So that would end up just being equal to 2 over root 2. So I'm going to go over here, and I'm not going to worry about rationalizing denominator. I'm just going to do that. Okay, so that's what the secant would be. The cosecant of pi over 4, its definition is r over y. Okay, in a unit circle, r is 1. Y is the same value, square root of 2 over 2. So that's just the reciprocal. So that would also be 2 over root 2. So then what you would do, of course, this is just equal to 1, would be the value of that limit then. All right. Okay. Next thing we'll look at is the power law. All right. So I'm going to go up to my laws here and just kind of show you how this power law works. So on the power law, if you have a limit of a function to a power, you do the limit of the function inside a set of parentheses, do that, then take it to the n power. Okay, so let's go down and let me show you how this one would go at the bottom of the page. So this one, you have a limit of x to a power. So according to the power law, you would do the limit as x approaches -3 of x, then the whole value of that limit goes to the 4th power. Okay, So this would just be negative 3. You would plug in the negative 3 in for x, work that out, you would get 81. That, of course, is just negative 3 times itself 4 times. So that's a positive 81 is how that would go. Okay? And then the last one on the next page is the root law, which works just like the power law. So up in my laws here, if you do a limit of a radical, then you do the limit, and then you do the radical of that limit, like that. So that's what that says. Okay? All right? The thing on this is odd and even roots make a difference. So the key thing is, I guess the key thing is if you have an even root, like if you have a square root, you can't do a square root of a negative. You can't do a fourth root of a negative. So that value of that limit has to be a positive number if it's even. Now if you have an odd root, the odd root of a negative number is okay. Okay, that's kind of what that little condition at the end is saying. Okay? All right, so I'm going to go to the next page, and I'll show you how this works out. So this is going to go like this. We have an even root. So what we do is the limit of the function under the radical as x goes to 0, and then we're going to do the fourth root of the entire thing. So that's how that gets put together. Okay, so what we do, plug this in, you would just have the fourth root of e to the 0. So that is the fourth root of 1, which is equal to 1. Okay, and remember, a fourth root, you're looking for a number that you multiply out 4 times that would give 1. So that number is 1. Okay, so that gives you an illustration of each of those properties. All right, so the next thing I'm going to show you is going to work out some problems that are good exercises to take students through, because the only way you can really do these limits is to show that you understand how the limit laws work. So in this exercise, I've given 3 limits. This is the limit f of x approaches 1. Second one is the limit of a different function, x approaches 1. And this is a third function, h of x. Now they all approach 1. They all got to approach the same number to do what I'm going to do on these examples. So what we're going to do on each one of these is we're going to use limit laws to work these out. Now I realize as a teacher that students can do a lot of these in your head, but the goal of this is you want to write your steps in such a way that I know that you know the limit laws. So this one basically is the constant rule. Okay, and I'm going to kind of go back and refer these as I go. This is rule 3. Okay, and it would be a good idea to just kind of write down which these are as we go. So according to that rule 3, the constant comes out. So you would write down 4 times the limit as x approaches 1 of f of x. And the limit of f of x is given as 8. So that would be 4 times 8. Therefore, the answer to that problem would be 32. All right, so that's what I'm wanting you to do on these problems, is show that you understand how the limit laws work. Okay? All right, next one, you're going to use the quotient rule. Quotient law is number 5. Okay, so let's just kind of write that on here. Rule 5, this is the quotient law. Okay? So you do this. According to the quotient law, if you have a limit of a fraction, you do the limit of the function in the numerator. Again, x approaches 1. Don't be lazy about x approaches 1. You need to develop the habit of doing that. And I know students get tired of doing that, but you need to do that always. Limit x goes to 1, h of x. So that's how you apply that limit law. Then if you look at this, the limit of f of x was given as 8. The limit of h of x was given as 2. So 8 divided by 2 is 4. Therefore, that's the solution of that problem. Okay, now the rest of these problems we're going to combine laws on. Right, so I'm going to kind of show you, this one right here has more than one law to it. So the first thing it has is this one is going to be a limit of a difference. So it's going to be that difference law, which is number 2. So we're just going to say on this Rule 2 difference law, okay, and let's start that way. So according to the difference law, what you would do is you would do two limits. The first thing you would do is the limit as x approaches 1 of 2 f of x, that's 2 times f of x, and then minus, and then another limit of 3g of x as x approaches 1. Okay, now we're going to use the constant rule, which is Rule 3. Okay, so this says that you can bring, if you have a constant times a function, it's got to be times now, then that comes out. So you would write this as 2 times the limit as x approaches 1 of f of x minus, bring the 3 out, 3 times the limit g of x as x approaches 1. So that's how you break that up. Now you're ready to get this worked out. The limit of f of x is 8. That was something I gave you. The limit of g of x was 3. I gave that to you. So this is ultimately what you work out then. So that would be 16 minus 9. So the answer to that would be 7. All right? Okay, so that's how that one gets put together. So the rest of these problems we're going to be combining some rules on. All right? So you want to show that you know how to put these together in order. All right, the next one, the first thing we're going to do on this is we're going to do the quotient law to begin with. That's rule number 5, I think. So this starts off like this. You would say the limit of the numerator, for now, f of x, g of x, divided by the limit of the denominator. Okay, like that. So that's how you'd want to start the problem out. All right, then we're going to look at the numerator. The numerator, we're going to do the product law for limits. So we break that up. So we're going to write the numerator as limit x approaches 1 of f of x multiplied by the limit x approaches 1 of g of x, and then all divided by limit h of x as x goes to 1. Okay, I want to break that up like that. Now these problems are easy to do because it's arithmetic, but it's the key thing is learning your laws. So the limit of f of x is 8. I gave that to you. Limit of g of x is 3. I gave that to you. Limit of h of x is 2. So you do 24 over 2. So that works out to be 12. Okay, so the key thing is write those steps out this way, showing that you know the limit laws before you just crunch out the arithmetic. A lot of times students just plug in numbers and don't prove that they understand the limit laws, and that's what you're trying to do. Okay, I'll do one more illustration, then I'll probably let you guys do a few problems to see if you're on top of this then. So this is going to be the root law on page 1. So if you have a third root of an entire function, you write this way. First of all, you do the limit as x approaches 1 of the function under the radical, which is f of x, g of x, plus 3. Okay, then you do the third root of that whole thing. All right? Underneath that, we're going to need to use the sum law, since we have a sum of two functions. So again, we're going to do limit like this, limit of the first function, f of x, g of x, as x goes to 1, and then plus the limit of 3, which we can figure out. I didn't give that to you because I don't have to. And then that whole entire thing comes under a third root. Okay, like that. All right. Now we're going to use the product law. And on the product law, you break this part up like this. So this goes like this. You do the limit of f of x as x approaches 1 times the limit x approaches 1 of g of x, and then plus the limit of 3 as x approaches 1, and then you're going to do the third root like that. Okay? All right, now we're ready to plug in. Okay, so if I go back up to what I gave you on this, I've kind of forgotten. Looks like we have this. Looks like we have the limit of f of x is 8, the limit of g of x is 3, and then the limit of 3 is 3. Okay, let me just kind of remind you of why that is. The function y equals 3 means that you have a horizontal line. So if you were to look at the limit as x approaches 1, the only value it could be is 3. So if you went from the right and went from the left, you'd have a value of 3. So that's what you get, okay? Anytime you have the limit of a number, a constant, the constant is the answer of that limit. So then to finish this up, what you would have is you would have this. You would have the third root. This would be 24 plus 3. So that would be the third root of 27. So what is the third root? Third root means what number do we multiply out 3 times to get 27? That answer is 3. Okay, so that's how that goes. Okay, so this is a good point for you guys to pause. If you need to get anything written down, just pause and do that. And then what I want you to do after you pause is just move to the next page on your notes, and then I'm going to have you do the 3 problems that follow. Okay, so I'm going to go ahead and move to the next page, and I'll let you pause the video and see if you can work these out okay, and then come back and check your result. Okay, so I'll have you go ahead and check your answers, see if you got everything right on here. So I got 8 on the first one, 125 on the next one. Now those two right there you can do in your head, and again I realize that, but you want to make sure you're writing out your steps the way I'm trying to show you so that you learn your limit laws effectively. The next one, some of you may have got down to 6 root 8 and didn't finish. Now remember, when you simplify square root of 8, you break that down in square root of 4 times square root of 2. 4 times 2 being 8, the square root of 4 is 2. So you get 6 times 2 root 2, or 12 root 2. Okay, that's how that goes. Look over what I did, and then that will end up our section on here. We're going to do this, I think, in multiple parts because this is a fairly long section. All right. Have fun.